a lot of what's here, I'm going to let you investigate for yourself. I don't know why I picked a straight line here, to be honest with you. Maybe this was a bad choice because it's hard to see that it's a reflection. But if you draw that and its inverse and the line y equals x, you will see that see how the inverses are related. The purpose of that is because we want to look at the inverse of an exponential function. Because the inverse of an exponential function, what's the inverse of this going to be? If I switch x and y here, I get x equals 2 to the y. If I solve that for y, how do I solve that for y? What can I do to both sides to get that by itself? Yeah, log, right? Log base 2. Log base 2 of this, log base 2 of this. Log base 2 of x equals log base 2 of 2 to the y, or in other words, just y, right? Y equals log base 2 of x. So there's the function. Here's its inverse, right? There's the inverse. That's the inverse solved for y. So you're going to put both graphs on here, and you're going to see how they're related to each other. You already know how they're going to be related to each other, but just to see the shape. Maybe beforehand predict for yourself if the exponential graph looks something like that, except I missed the points, and it has a horizontal asymptote, predict what's going to be true about the log graph after you reflect it. Okay, so that's step number one that you're going to do in a minute or two, unless you're getting ahead of me and already doing it. Then what I would like you to do is compare what happens for different bases. Log base 10 of x, log base 2 of x. Think about where log base 5 of x would be, and then be able to say how the base affects it. Some of you might be able to draw these graphs without thinking of them as their inverses. If you're trying to draw the graph of log base 2, just think of numbers that are easy to do without a calculator. Like if I asked you to draw the graph of y equals square root of x, you might not know what the graph of square root of x is, but you could do it with a table, right? You could do it with a table just by picking nice numbers for square root of x. What kind of numbers would you pick for x here? 4, 8, 8, you'd pick 8. Why am I listening to you guys? 2. You'd pick 2? Oh, you're thinking of this one now. You'd pick 1, yeah. If you're doing square root, it's because I changed it and then I forgot I changed it. If you were thinking square root, what would you pick? 1, 4, 9, 16, 25. You could pick 0. Okay, all of those things. If we are doing now this, we're not doing square root, we're doing, say, log base 2. There's a couple different approaches you could take. You could take the approach of, well, just think about this function and then reverse the coordinates, if you like. You could just say, I'm thinking of this, right? And a point on there is when x is 1, y is 2. So that means that on this graph, what point is on there? 2, 1, right? Does that make sense? Or if, right, like you could make a table for this, or think of a table for this, right? When this is 1, this is 2, and this is 2, this is 4, 3, 8. And then you could say, well, to make it the inverse, I have to just do this, right? Switch this. Or you can just think for yourself, hey, I'm pretty clever, and I can think of log base 2. I'm getting better with log base 2. Log base 2 just means think of powers of 2, right? When you're thinking of things for square root of x, you're thinking of what is easy to take the square root of. Well, what is easy to take the log base 2 of? Not 7 or 10 or something like that. What kind of numbers are easy to take the log base 2? Yeah, 8, 4, 2, 16. Powers of 2, right? 16 is the 4th power of 2. 8 is the 3rd power of 2. 2, 1, and so on, right? Now, don't forget about numbers that are not, that are, maybe you don't think they're easy to work with, but I would leave some space before that, because you can put a 1 here, you can even put a 1/2 here, or a 1/4 here, and so on, right? You can put numbers like that and think about what their values are. For the same reason that the exponential function can't be below the axis, a logarithm function can't be in a certain place on here, but let's make sure we draw the graph fully. There's no end point for this graph. It isn't going to start in a certain spot. It's not going to start here and kind of end there. When you draw it, realize it continues and draw it nicely. Okay, and then you're thinking about this. That might take a while to truly understand that. And then when you're okay with it, you can start thinking of, well, how do I do some transformations of this? Transformations as in, well, if I change the x to x plus 3, how's that going to change it? Instead of x, I get x plus 3. It changes it the same way as it does for a quadratic. If you take a quadratic and change it to x plus 3, how is that going to change it? How does that change a quadratic? If you have x squared and you change it to x squared plus 3, it goes there, 3, right? No different from this. Quadratics are easier because they have this vertex, and that's kind of how you, I think in grade 11, keep track of them. The problem with these graphs is there's no vertex to keep track of because they don't pass through the middle. So you have to think about where the asymptote is going to go. Okay? Anyways, that's probably more than enough of an intro to get you going on this. We're going to get partway into this. You're going to start to think about how some transformations happen. Don't rush into the transformations until you think you understand what the basic thing is here. You should be able to say what you know about the asymptote for a log graph, how it compares to the asymptote for an exponential graph. You should be able to say what point is it always going to pass through, how the base affects it. You should be able to answer some of these questions before you move on to transformations. Okay? Again, that's probably more than enough to get you started on this. You can use the time you have now to get through that. I'll answer questions, ask other people, ask me. We're going to do the quiz after lunch, and then we're going to continue working on this. If we manage to get this and the quiz done and marked and everything today, I think that's good. That would be a good goal.